So welcome to another demonstration of the Atom calibration framework. In particular, now we are focusing on the functionalities of the calibration stage. So I will launch a calibration for this particular data set and considering only 5 collections. So the script is going to do the optimization, but also to send information to ROS in order for us to be able to visualize. So this is again the mmtbot. We can see here the poses of the robot for these collections. We had 5 collections, but probably 2 of those collections are with the same robotic pose, because we can have collections where only the chessboard pattern changes and not the robot's pose. And so here we can see the chessboards as well. I can take away this. So this is the estimated chessboard pose. We have the corners with these colored cubes. Then the physical boundaries of the pattern with this same color small cubes here on the boundaries. So this is the information we generate from what we know about the pattern and where we are estimating its pose. And then the optimization is a matter of comparing this information with information that we are receiving from the LiDARs. So in particular, the information from the labeling of the LiDARs. So for example, we know that this, we can put a single, let's just, for example, show a single one. So we are just showing collection number 0. I'm also going to show only collection number 0 here. Okay, so this is a single collection, and we know that something has to change, either the position of one of the sensors, or many of the sensors, or some of the sensors, or the position of the chessboard must change in order for these points here to be on top of the chessboard. Okay, so and this will be the orthogonal distance cost function. Then we also know that there is a longitudinal alignment where we should change the points more to the left or to the right. And so we can visualize everything that's happening for one or many collections with this calibration tool. For now, the calibration is not being executed. We are just, the system is just waiting for me to give it the go for starting the calibration. And we can just go back to the visualization of all these collections, all 4 of those. Here, oh, no, this one I have, the patterns, namespaces. So this is well integrated into RAWs and RGs, so we can just, we have many options of what to see and what not to see. And now we're just going to start the calibration. And you can see the sensor is moving. So the sensors move because the pose of the sensors changes, as we are estimating its pose, different poses, and also the chessboards have moved. And in the end, we ended up with a good alignment between those points, which were the measurements from the LiDAR, and also the place where we estimate the pattern. In this case, the sensors are not in the correct position, so the camera is too far close in front. The actual position is in this horizontal bar, but this is happening because we don't have enough information. We are just using 5 collections and not all 30 of them. We can also see the images. So for example, we can visualize, we were looking at collection 0, so let's just visualize for collection 0 the hand camera. And so here we can see the images. The squares are the ground truth coordinates, so where the projections should be. And then we have dots, which we cannot see very well now because they are too small, but I can enlarge this image. So the dots are in the middle of the square, so this should be close to 0 reprojection ever by now. So we can visualize this one and then also the other one. Let's just start a new optimization with all 30 collections. So let me just say all collections smaller than 35 are going to be used. Of course the system now it becomes heavier because we are drawing a lot of stuff. So the goal here is not to run the calibrations with all this visualization because this is computationally demanding, but at least to be able to test and see if everything is going well, then we run this in headless mode. So here we have a lot of stuff. We can see either these images or some other images. For example, let's take a look at the hand camera for collection 12, which is different, of course, because collection 12 had a different pose. And now we just start calibrating. I think I have to run this again. Okay, we can run it again. Okay, now yes, it's running. And so, if all goes well, we will see the poses of not only the sensors but also the chessboards, because their pose is also being estimated because we have extended the standard optimization problem in order to include the pose of the chessboards. So everything now seems to be converging to the real position. You can see here that, as expected, the camera and the leader are on top of the bar. Also, the camera on the end effector, so the hand camera is near the end effector where it is in the reality, and the data from the leader and the data and the estimated pose of the chessboard is very well aligned, as are the points which are being projected. So these are the tools for supporting the visualization of the calibration in After. Thank you.